So we go to the second chapter, which is very closely related to chapter 1 in the sense that you have to solve the equation in chapter 2 using what you have learned in chapter 1. Yeah, elementary row operation. That one you reserve. That is very specific, right? The question, I know somebody will ask that, but reserve that to the end. We cannot find the square root in general. How do you find a square root in general? Right? Tapi ada student buat macam ni. Tak tahulah siapa aja. I didn't. Okay. If you have x squared is say 2, x is like square root of 2, right? This is the square. So if you have a matrix, x squared is A, you want to find the x. So you have to do this. You have to multiply whatever is given, right? A is given in the question. So this is A squared plus BC equal that. This is equal that, right? So you will have 4 equations. Then you solve that, then you will get A, B, C, D, which is your square root. Siapa yang tanya tu cuba angkat tangan. Nurin? Nampak dekat chat je. If you raise your hand, I will see you. Okay. Nurin, does that give you a hint? You can try again, yeah? So the question give you, its square is A, x is actually square root. It's not exactly to find the square root as the normal square root take each. There is no formula, but let the square root be like this. So you know x squared is A, you multiply it twice, equal the A, and then you get the equation. So like A squared plus BC, suppose I call this M and PQ. Number, ada number ni bagi? A squared plus BC is M, right? AB plus BD is N. You will get equation. And then with whatever that you have learned from before, because this is actually chapter 2, the equation. Okay. All right. Reserve other question later because I want to start for this chapter 2. Okay. Chapter 2 is all about system of linear equation. You have learned this, I'm sure, in high school, in secondary school. Yeah, system of linear equation. And system of linear equation has so many applications. And definitely because linear algebra is a must for not only the mathematics student, but also the computer science students, because they learn a lot also in like sangat banyak lah. Right? I'm not going to go into all the literature review for this, but Google after this, see the application of system of linear equation. There's so many. Pergi pasar pun boleh pakai system of linear equation. I think you still remember question from your secondary school, like if I buy this 3-pack of this and 2-pack of this, it costs how many ringgit, right? And then this, how many ringgit, and how much each costs, something like that. That is linear equation. Okay, and actually using linear equation, you can further your study or your research to up until maybe PhD using something with linear equation. One of my PhD students is now trying to solve problem regarding the research, PhD research using system of linear equation. So that's why we learn about this not only for mathematician, but also in others. Okay, electrical engineers also. Tapi dia tak adalah ni kan, dia just use the peranti-peranti adalah software dan sebagainya kan. But who created that? We created that, and then they do the algorithms and the software. Ni tak? Okay. All right. So if you look at the content, right, there is this introduction is what is actually the system of linear equation, and you will see there are many types how to solve a linear equation. The first one is Cramer's rule. You have seen this also in secondary school. And then inverse of a matrix method. Probably you have seen this also. So to find the inverse first of a matrix is chapter 1, right? To solve the system of linear equation. And Gaussian elimination. Have you heard about this method? Gauss? Yes or no? Okay. And Gauss-Jordan elimination method. Yeah, some yes, probably some no, probably some don't remember. So Gauss is actually using row echelon form. Okay, Gauss is using row echelon form. Gauss-Jordan using row reduced echelon form. So you see, that's why I said if you don't understand and don't know how to do elementary linear operation, you won't pass this class. Yang ini betul ya, ini bukan main-main macam ambil gambar tadi. This is seriously, okay. And I will mention about homogeneous linear equation and non-homogeneous, and how do we determine the solution of a system of linear equation, because sometimes you need to check whether the answer is unique or not. Okay, let me start with the general system of linear equation. System of linear equation. Many systems, right? So we put many equations. We have to understand what does it mean by system. System means you are given maybe one system. System is system. Linear equation, what does it mean by linear equation? What does it mean by equation? Equation is an expression that has an equal sign, right? That is an equation. And linear means it's to the power of 1. That's linear. Kita belajar macam ni kan? Ke C? B ke C? Dia all cakap C. Dia all cakap seorang tak unmute. Ni saya pun tengok. Sama je B dengan C. C lah. Okay, this is actually a system of linear equation with an equal sign, right? And the variable is y and x, and the power is 1. So it's a linear equation. But we want to write this in this form. A11 x1 plus A12 x2 plus A1 n xn is B1. So this one is like mx1 plus c is y1. Oh, sorry. x2 mx1 minus x2 is c. To rewrite what we learned before in terms of the variable, two variable with the coefficient, right? Equal the number. Okay, we want to write it this way. This, I will write down all, yeah, before I give. So the second equation with the same variables and the m with the same variable. So this Aij can be, I restrict to reals, yeah? We don't go into complex, but this can be also complex. I restrict into real. And also the B's also real number. Okay, I want it to be real number. And this X, Xi, the variables. Okay, it can take any values. That's why we call it variables. Okay, so all Xi variables is to the power of 1. That's why we call it linear. Okay, maybe some question, determine whether this is a linear equation or not. And that's a power of 2 or 3 is not. Okay. And how many equation? Coba type, how many equation?
The m times n number of equations too, madam.
Equation, 1 equation, 2 equation. How many equation? Until m. Only m equation. Okay. How many variables? How many variables? N. Because 1, 2 until n. And then we create a matrix. Okay, from this we can create a matrix. And we can write A, X is B. Okay, in which A is this matrix. And X, we normally put like this because this is the vector, and B actually is also like this. And this is the one that Yusuf mentioned about m by n is a matrix. It's an m by n matrix. You can multiply with n by 1, right? M by n and n by 1. Then you will get m by 1. So you see, we can transform the system of linear equation into matrices and vectors. This is called the column matrix, right? Column matrix, column matrix. Or before this, we see it as vectors. Okay. Okay tak okay? Okay. Tepuk tangan pula. Tersalah tekan lah Daniel. Okay. Good is okay. Now examples, yeah? Okay. So I give some examples. You write the system of linear equation. 2x minus half y equal to 3x minus 4 equal to y. Negative y, negative x, minus 1 is 0. Okay, I want you to find the A, the X, and the B. What's your answer? So we have 2, negative a half, 3, negative 2, negative 1, negative 1, x, y equal 2, 4, 1. Right? So x minus half y is 2, 3x minus 2y is 4, negative x minus y is 1. So this is an example in which the question did not follow the right order, but we have to follow the right order. Yeah? Okay. Now next question. You have m by n, right? We normally solve if there are 3 equations and 3 unknowns. Can we solve the equation? Yes or no? Type. If you don't turn on your video and then you do this or so. M equals n. Like 3 equations, 3 unknowns. Can you solve this? Okay. Okay. Next, if m is bigger than n, yes or no? You have more equation than unknown. Can you solve? Like this, right? Okay. What about if m is less than n? Yes or no? Okay, I'm still waiting. Yes or no? The question is, can we solve? Okay, can we solve it? Okay, the answer is yes. That is why you have to take this class. Alright, if you think dulu kan cikgu dia cakap you have to have the enough equation to solve, right? Ingat tak? Saya ingat cikgu saya cakap dulu. But that is to get a unique solution. Okay, so you have to get actually at least not equal to get the solution or unique solution. Okay, if the equation is less than the variable, kita semua memang tak boleh solve kan, tak boleh dapat jawapan. But in this class, I cannot say everything is possible, but it's possible to solve whether there is a solution or not. There might be no solution. Okay, so we will see in all of the cases. Okay, now semut lah bagi ni, manis sangat ke saya? Gitu. Semut. Okay. Right, I still have 5 minutes before our break. Maka ni tak dibuka pula. Ish. Tak dibuka. Plastik dia. Don't know what happened to the plastic of this marker. Okay. Okay. Let me give this one very easy example. Yeah. X plus y is 2. Okay. X, y in R. What is M? What is N? Type. M is the number of equation, N is the number of variable. Eugene, lepas ni saya nak block lah Eugene. Eugene dah tak boleh jawab ya. Sorry Eugene. Okay, so one equation, two unknowns. Yeah, one equation, two unknowns. So M is less than N. Right? And then tadi cakap no kan? Saya sukalah tengok Nabila Huda hari ni, dia senyum aja. Nabila, give me a pair of number, okay, x, y in real such that x plus y is equal to 2. Can you give me a pair of number? What is x, what is y? X plus y is 2.
1 plus 1.
Okay. Alright. Nak cari yang tak on video. Suhada. Suhada.
Saya, doktor.
Jauh sangat suara dia kan? Give me another pair.
2, 2.
Ha? Kejut saya.
Tak. Mula, doktor.
X plus y is equal to 2.
0, 2.
How many possible solution? How many? How many possible solution? Shuhui, you want to give another one?
Negative 1 and 3.
Negative 1 and 3. Yes. Infinitely many solution. Right? Infinitely many. If you give any y, x is 2 minus y. Give me any y, x is 2 minus y. So you get, give me y, you get x. Give me y, you get x. Right? So infinitely many solutions. So in this class, we will solve this and determine, given a bigger system of linear equation, using methods that we have, and we get the answer. Whether there is no solution or there is a unique solution, only one solution, or many solutions. So 3 different kinds. Okay, this is just a introduction that I want you to think about. If I have another one, this is what we have learned before. Can you solve this? This is a system of linear equation in which m is 2 and n is 2, right? How do you solve this during class? Muhammad Nabil? You remember? How do you learn in class before? Oh, bila-bila lah sebelum ni. How do you solve this?
Use the method like the method that you showed before. Yeah.
So can you explain to me how you solve this?
Firstly, we write 1, 1, 1 negative 1.
This is what I learned.
Oh,
This is what I learned, I remember, from 4 to form 5. And then I put 1 plus 2, then I get 2x is 3, x is 3 over 2. And then substitute this in 1. Substitute in 1. So 3 over 2 plus y is 2. So y is half, right? And then you check. So x is 3 over 2, y is a half. And when you check x plus y is 2, x minus y is 1. Ni yang saya belajar dulu lah di sekolah. I don't know how do you learn? Did you learn the same way or not? Yes? Nabil? Yeah. Dah ingat balik? Ke tak ada? Okay, this is what we learned before kan kita ni. Alright, so this means it's a unique solution. Just now it's infinitely many, right? Now it's a unique solution. Okay, next. What if I put this like this? What's the answer? Can you type the answer? Eugene, you are already blocked, yeah? Kejap lagi Yusof pun kena block juga. Okay, what's the answer? Syntax error. Tadi saya bagi 3 je kan? Infinitely many, unique, or no solution. So Amirul Zakwan already answer, no solution. If you do my way, the way that I learned during school is if I minus, right? 2 minus 1 or 1 minus 2, what do you get? 0 is 1. But 0 is not 1, right? So there is no solution. No solution, right? If you have x plus y is 2, how can x plus y is 1? Crazy kan? Macam itulah. Alright. Okay, so this is just the introduction of the whole, but I did not change yet for m bigger than n, right? So I just give one more. If I give like before, and I add another one. Okay, just now before this, you said the answer is unique, right? Without this, you said the answer is unique, right? But with this, if this give you just now 3/2.5, but if you put in here, you get 3/2 plus 1, which is 5/2, which is not 1, right? So this is also no solution. This is also no solution for this one. Because if you solve this, you get this, but if you want to put in here, you get 3/2 plus 1 is 5/2. Okay, so in that case, there is no solution. In that case, I didn't say in general, right? For n bigger n. But if I change this to 5/2, right? This will be unique. Because by this 2 you get this, by this also you get it equal, right? So it's unique. Is it possible to get many solutions with this case? Yes. If I have something like this, right? You remember the one that we have just that, or plus 2? Oh, one. You can put, without these 2, you can get many solutions, right? 0, 1, 1, 0, half, half. If you get that, because they are actually equal, so you get that many solution also, and that's also equal. So with m bigger than n, there's a possible to get many solution. Okay. Okay for the introduction. Okay, tunjuklah jempol tu. Orang Jawa kata jempol. Melayu kata ibu jari. Oh, putih. Your thumbs up. Okay, we break for 10 minutes. Okay. So I mentioned earlier about this. Yeah. This is called the coefficient matrix. Kenapa saya pakai corporate ni? Baju corporate. Because I had to go for audit session at 9:30. So after this, Hannah and Shiham will take over for the tutorial session. Yeah, and then at 9:58, Hannah and Shiham will take another group photo. I want to see who is here until the last. Okay, so coefficient matrix and X is the solution. All right, X is the solution for the system. All right, so I mentioned about this 4 method, yeah? Cramer's rule, inverse method, Gaussian elimination method, and Gauss-Jordan. Elimination method. Okay, so for Cramer's rule, we have xi is equal to ai over a. You have seen this before during your high school, actually. In which AI is the matrix A, by replacing the ith column with B. Yeah, this is. So as an example, suppose we have x plus y is 2, x minus y is 1, like just now. So we have 1, 1, 1, negative 1 times xy is 2, 1. Right? So you will write x equal, so you take the A, but you replace, because it's the first one, right? X1, you replace the first column by B. So 2, 1, 1, negative 1, divide by, so before this, before finding all, so you find the determinant, right? The determinant of A is negative 2. Negative 1 minus 1 is negative 2. I just put like this. Right? So this is negative 2 minus 1. Negative 2 minus 1 over negative 2 is 3 over 2. And then y is actually x2. So instead of x1, x2, we can also have x and y. So y is A with the second column replaced with B. So we have 1, 1, 2, 1 over negative 2. And this is equal to 1 minus 2 over negative 2, which is 1 minus 2 is negative 1 over negative 2 is a half. You see, this is the answer that we have before, right? So this is the formula using Cramer's rule. So if you have 3 by 3, then you have to do x1, x2, x3. So imagine if you got the wrong determinant. Imagine if you get the wrong determinant, all answer will be wrong. Okay, so make sure for determinant is very crucial. If it's 3 by 3, meaning even the matrix determinant is 3 by 3, right? This is 2 by 2. Okay, that is Cramer's rule. So to find each variables is to find the determinant of the matrix A by replacing column I with B. Okay, easy, right? Easy. Okay ke tak okay? Hey, orang yang dah kena block pula yang jawab. Okay, okay, okay. Kentang, Nabil? Kentang bersanggul ke apa tu? Alright, now inverse method means, yeah, I go for inverse method. This is by, okay, this one is like this. Inverse method says X is A inverse B. That's it. Find the inverse, multiply by B. But for these two, this works only if determinant is not 0. Okay, and this is only for a square matrix, because to find determinant, it has to be a square matrix in the first place. So these two cases is restricted only to square matrix A when M is equal to N. Okay, but we have another two cases, right? M is less than N and M is bigger than N. So these two cannot be used. Even if M is N, but if the determinant is 0, still cannot be used. So the safest way is to use this one. If the question is not given which one to use, normally we will give, otherwise you will use so many. Okay, what about this method? This method says you have A and then you put B instead of before we use inverse, right? Inverse to put I at the end, but this one you put A, you put B at the end, and then you row reduce under row operation, and then you will get R, E, M. And you will get to REM, reduce echelon matrix, and then you will get another set of B at the end. And then you solve using back substitution. Solve using back substitution. Back substitution is the one that I mentioned, the time that I learned in class, sekolah menengah dulu. Using B, put B equals this in one, that is back substitution. So you will get answer and then you use and put it back to get the other one. For this one, okay, you use also ERO, but you change until RREM. That's the difference. Okay, for this one is until row echelon, but for this one it's until row reduced echelon form. Okay, so for this one, let's try the same matrix. 1, 1, 2, 1, negative 1, 1. Betul tak ni tadi? Is that the right matrix just now? Saya dah padam pula. Yes? Nabila? Yeah? Okay. Right? This is, yeah, okay. So reduce, yeah? So I get negative row 1 plus row 2. So get 1, 1, 2, 0, negative 2, negative 1. One more, negative 1 over 2, row 2. 1, 1, 2, 0, 1, a half. This is row echelon matrix. Okay. Saya setiap kali nak senyum, macam hesitate because somebody write in your comment, saya nampak cute bila senyum. Teringat lagu cute tu. Dia jadi hesitate nak senyum. Jadi macam potato Nabil tadi, yang tu yang cute. Okay, so this one, this is already a row echelon because there is 1 and down here is 0 and there is 1. Yeah, so this is the REM. And then you remember your question, yeah? You put X and Y on top, that is your variable. Okay, then you write back. You write back X plus Y is 2. Y, this is 0x, Y is a half. So this is reduced, right? Then you can back substitute. So put in here in 1, so X is 3/2. Then you get the answer. That is why I said it's using back substitution. Okay. Now, using the fourth one, I have to go one more, right? Because this is not 0. So this is Gauss. This is already Gauss. One more is to make this 0. Negative row 2 plus row 1. Okay, you won't change this. Negative and add, negative and add. Okay, I'm not saying that if it's at REM, it's always you will get the right answer right away. For unique, yes. Okay, if it is unique, you will get the identity matrix here. Then you get directly the answer. But we might have the case that it's not unique, right? When m bigger than n or m less than n. So in this case, when you read through, you get X is 3/2, Y is a half. So right away you get the answer.